Hey everybody, today we're going to learn how to read a chart called the Properties of Common Minerals. So this chart is very useful. It's kind of like a scavenger hunt. So if you have a lot of physical properties that you've identified, then you can use this chart to figure out what is the name of that mineral. Okay, so let's look how this chart is broken down. If you look at the very top, this chart is broken down into columns, with the very first column being luster. Okay. So your luster is either metallic or non-metallic. And then you have this one mineral that can vary called hematite right here. And this one could sometimes be metallic or non-metallic, and that's because there's a lot of iron in that mineral, and you can have it look very metallic or it could look like rust. So this one could have both kind of lusters, which is unique. Okay, but for the most part, we're going to say metallic or non-metallic. All right, the next column says hardness. So right here gives you the mineral's hardness. And 5.5 is glass. So if it's greater than a 5.5, that means that mineral can scratch glass. And if it's less, it means it can't. So we don't consider something hard unless it can scratch glass. All right. The next column is whether it has cleavage or fracture. And they put these little check marks. So the very first mineral in the first row has the check mark under the cleavage. So that means graphite. Graphite has a hardness of 1.2 and exhibits cleavage. And it's metallic. Okay? So if you found a metallic mineral that is very soft, so it comes off as soon as you touch it, that's like a 1. All right? And it splits on smooth, flat surfaces. That means it has cleavage planes. Then you probably discovered graphite. Okay? If the check mark is on the right side of this line here, then that means it has fracture. So a mineral like magnetite has a metallic luster. It can scratch glass because you see it's 5.5 to 6.5. But instead of having any cleavage planes, it'll break randomly, and that's what we refer to as fracture. Okay? I'm going to clear this a little bit because there's a lot going on. All right. Okay, the next row is the common colors. So we already learned that color isn't the best thing to go by. Streak is much more important. But some minerals are known for their color, all right, or will only have 1 or 2. So you would look here for common color. And then the next is distinguishing characteristics. So right here, distinguishing characteristics. Now this will allow you to distinguish or really tell one mineral apart from all the others. So this is probably the most important section. All right. So let's take the mineral pyrite right here. You don't have to memorize that pyrite is fool's gold because they're telling you right here in the distinguishing characteristics. And pyrite is the one that I showed you in the last class, video lesson, that even though it has a gold color, see, brassy yellow color, it has a green-black streak. So you don't have to memorize that. They're telling you that its streak is different than its color. Okay? Another mineral we learned about the other day was magnetite. What's special about magnetite? I mean, it's right in the middle of the word. It is magnetic. And they're telling you that right here. Okay? All right. So they give you a lot of information in these distinguishing characteristics. So this is, like I mentioned earlier, kind of like a scavenger hunt. You'll be given information, you'll be given lots of observations, and you got to kind of take the time, search through this chart, and find your answer. Let me clear this up a little more again. All right, next part is uses. So what do we use the minerals for? Okay. So right here, uses. So who remembers what mineral is in our pencils? And we call it pencil lead, but since you could kind of draw a graph with it, the real mineral is called graphite. And they tell you right here, pencil lead. It's also a lubricant. It reduces friction. So a lot of times if you have I made Pinewood Derby cars for my kids when they were Cub Scouts, and you're allowed to use graphite as a lubricant on the wheels axles so they spin faster. So graphite reduces friction. It's a solid lubricant. Okay. So what's the special use for galena? So you would find galena, you would go to uses, and it's an ore of lead. An ore means a precious metal that you could extract or mine from a rock. So the lead is inside galena, and what they do is they heat it up or melt it down, and then you can extract lead from that mineral. And galena would also be used in batteries. Okay. Now magnetite, which is very magnetic. Well, one of the minerals that's magnetic is iron. So it's an ore of iron. So iron comes from magnetite. And we can use iron to make steel. So the uses are how people as a society have realized useful ways we could use these minerals in our daily lives, whether it's industry or other practical purposes. Okay? And the next column is composition. So right here. So what elements are in these minerals? So Pb and S, that's lead and sulfur. Pb is lead. I don't expect you to memorize that. If you go to the bottom of this page, they give you the chemical symbols, and you would find lead right here. Okay? So iron and oxygen are in magnetite, and iron and sulfur are in pyrite. So you don't have to memorize that Fe is iron. I go to the bottom of the page and I look for Fe. And there it is. And S is sulfur. Okay, so they're only giving you the elements that are on this chart. So you don't have to use your whole periodic table that you learned about last year. Okay. Now I didn't go over the total bottom of this chart. I'm going to go over a couple of them right now that come up fairly often on state tests. And one of them would be something we learned about the other day. What mineral will bubble with acid? Now, where should you look so you don't have to take forever to do this? That's something that would really distinguish one mineral from another. So you would go to distinguishing characteristics. And yes, it's time consuming. You would read each little comment until you get to bubbles with acid. Okay? There's two of them. So one bubbles with acid, that's calcite. And then the other one says bubbles with acid when powdered, and that's dolomite. And the reason why both of these can react with acid is they have what's called a carbonate group, a CO3. And when acid hits the surface, it releases carbon dioxide, and that's why it bubbles. Okay, so these are both called carbonate minerals, and they're the only kinds that will bubble with acid. Okay, I'll give one other distinguishing characteristic from this chart. And that would be salty taste. So right here, so halite is table salt. So you didn't have to memorize that halite is salt. It tells you right here, salty taste. And then if you look under the uses column, it says right here, food additive, which means we add salt to our food. It also melts ice. So we add salt to the street in the winter to make it harder for water to freeze or to melt ice that might have already formed. Okay, because salt lowers the melting point of ice. So water would have to freeze at a much colder temperature. So if you weren't aware, that's why we actually add salt to the roads or to your sidewalks on a winter day. All right. One last use, because I want to go over this term, and that is abrasives. So an abrasive is something that wears something down. So sandpaper is an abrasive. So anything that could grind something down into a powder or smooth out edges, we would say that material is abrasive. So it would have to be hard. You'll never have a soft abrasive. Okay, so anything listed as an abrasive is very hard. Okay, so there'll be a series of questions tied within this lesson. All right, make sure you have this chart out, because otherwise you'll just be guessing. All right, as always, email me with questions, or I'll see you or ask them at the Google Meet.